So this is going to be the first video for Notes 40. I'm going to break it up into a couple different ones, and this first one we're going to talk about imaginary numbers. And basically the idea with imaginary numbers is they are numbers that are perfectly fine. They're wonderful values. You just can't graph them on a number line. All right, or at least not a real number line. So one of the things you need to know is that by definition, this is a definition, I is equal to the square root of -1. We define I this way. It's really no different than saying pi is equal to 3.14159. It's just something that we have defined. If I take this original equation, I is equal to the square root of -1, and I square both sides, well, I squared becomes, well, I squared. And the square root of -1 squared becomes, well, just -1. So in some problems, when you are working with things, and you create an I squared, you can just replace that with -1. Now, let's say we want to simplify with some imaginary numbers here. The first thing I do with any imaginary numbers, I'm going to start with part A over here, is I am going to break out the negative. I'm going to separate the -1 from the other value. So I think we would all agree that, whoops, let's try that again. 9 times -1 is -9. All right, so I haven't done anything weird. Now, the reason I do this is because I know what the square root of 9 is. The square root of 9 is just 3. And I know that the square root of -1 is I. So that's how you can simplify with a imaginary number there. All right, it's a square root with a negative. So for part B, I'm going to do the exact same thing. I'm going to break out the negative, so square root of 49 and then square root of -1. Square root of 49 is just 7. It's a perfect square. And the square root of -1 is I. So 7i. All right. So far, so okay. And then we get to part C, and I'm going to start it the exact same way. And I'm going to do the square root of 20, and then the square root of -1. Whoops, square root of -1. There we go. And unfortunately, this one is a little bit different because the square root of 20, I don't know off the top of my head. Now, if you know your perfect squares, you can look for a perfect square. I know a lot of my students, you guys like to use the prime factors. So let's go ahead and do a factor tree here. Let's see, what can multiply to 20? How about 2 and 10? And then at 10 would be 2 and 5. And I'm just circling them because they're primes. So 20 here, I'm going to replace with 2, 2, and 5. And then I've got, of course, the square root of -1. So when I'm looking to do this, the reason these prime factors are great is because if I have a pair of prime factors, when I take them out of the square root, I just get that number. So when I have a pair of 2's like this, I can pull the 2 out front. The 5 that didn't pair up stays underneath the radical. And then the square root of -1 is I. So the square root of -20 simplifies to 2 root 5 I. Okay. Now, it's not, the way I just wrote it is 100% mathematically accurate. You will sometimes maybe see it as 2i root 5. Because it's all multiplication, it really doesn't, the order doesn't particularly matter. I have seen some teachers, and myself included, I sometimes write the I in front of the root to make it very clear that the I is not under the square root. So that would be one reason to do that. All right, I'm going to go ahead and slide on over. Let's take a look at D and E here. So same kind of situation. We've got the square root of -48. So I'm going to do the square root of 48 and then the square root of -1. So let's see. If I wanted to do a factor tree on 48, well, let's see. That would be 6 times 8. 2 times 3. Those are both done. Let's see. 4 times 2. 2 and 2. That is a lot of 2's and a little lonely 3 there floating around. All right. So let's see what we got here. We've got, where's my highlighter? There's my highlighter. 1, 2, 3, 4 2's. So 2, 2, 2, and 2, and then the 3. Multiplication dots between those, and the square root of -1. So let's see what we got. We have a pair of 2's. We have another pair of 2's. So from the first pair of 2's, we take out a 2. From the second pair of 2's, we take out a 2. What didn't pair up stays underneath the root. Square root of -1 is I. So 2 times 2 is 4 root 3 I. All right. Not too bad for part D there. And I think part E is going to be the last but not least part of this one. So, of course, save the best for last. Square root of negative 72. I already took out the square root of negative 1 there. So let's see what we got here. We've got 72. Let's see. 2 times 36. 6 times 6. 2 times 3. 2 times 3. 2. Let's see. Yep, that works. Okay, so I've got 2, 2, 2, 3, and 3, and then a square root of negative 1. Okay, so I've got a pair of 2's, and I have a pair of 3's. So I'm going to take a 2 out, I'm going to take a 3 out. What didn't pair up stays underneath the square root. Square root of negative 1 is I. So 6 root 2i. All right, that is going to be the end of this first video on imaginary numbers. As always, please let me know if you have any questions or concerns, and I look forward to seeing the next one.